In this unit, I'll address issues related to soils in urbanized areas, with specific reference to soil characteristics necessary to support plant growth in such environments. In addition, I'll discuss the use of artificial soils developed specifically to address special needs in the urbanized context. Urbanized areas are expanding rapidly within the United States. According to the U.S. Census Bureau data for the year 2000, approximately 79% of the entire U.S. population and 77.4% of the Ohio population is considered urban. Urbanization is not only an American phenomenon, it is a worldwide issue. Urban areas often expand into surrounding forest land, rangeland, or agricultural land areas because these areas are adjacent to existing urban areas. The expansion of urban areas has significant consequences for soil quality. Prime farmland with its high-quality soil is vanishing at an alarming rate in certain regions of the United States because of urban expansion and development. For the decade of 1982 to 1992, 1.8 million acres of land came under urbanization. In the following half-decade, between 1992 and 1997, the rate of land conversion to urban use had shifted to 2.2 million acres per year. That represents a 36% increase in rate. Soils that are best suited to other uses, such as providing food and fiber, are commonly the easiest to use as sites for homes and cities. A locally relevant historical context for changes in land use is demonstrated by the extensive gardens that were part of the Ohio State University campus in the 1920s and 30s. Keep your eye on the iconic smokestacks of the university's power plant, circled in red. The same smokestacks reveal a dramatically changed landscape that has led to a more intense urbanization of the Columbus campus. These activities are typical of changes that occur throughout the state and country and that have strong influences on the quality of soil and its ability to support growth and development of plants. Urban areas occur all across the USA, from coastal areas to areas high in the mountains, and soils occur in such areas as parks, playgrounds, lawns, and gardens. These soils are similar in some ways to soils in rural areas, but in other ways they are very different. Soil properties, such as soil texture and structure, particle size distribution, soil reaction, and bulk density, help us to understand and predict how soils react and respond to different uses. Construction activities, compaction, and surface sealing dramatically change soil properties and can sometimes result in a reduced ability to perform the critical functions or activities of natural soils. Extensive study and analysis by soil scientists in universities and at the Natural Resource Conservation Service has resulted in a broad understanding of urban soils. Examples of excellent resources about soils in an urban context are the books by Philip Kroll and also recent publications by the NRCS. Some unique features of urban soils have been described succinctly by Philip Kroll. Urban soils have been disturbed, manipulated, or handled in some way that changes or modifies their properties and attendant characteristics that may present poor plant conditions. There are very few urban soils that do not exhibit evidence of modification in some degree. Differences in urban soils have been observed and recorded by scientists, engineers, equipment operators, and construction workers for a long time. Within urban areas, there is a multiplicity of soil conditions, ranging from natural soils that are relatively undisturbed to soils in which the natural materials have been mixed or truncated, to soils that formed in added materials or fill of varying thickness. Each of these areas in turn can be subject to different types of use and management which can further affect their soil properties. Generally speaking, soils in urban areas can be divided into two general types: natural soils, which formed in material naturally deposited by water, wind, or ice, or in material weathered from the underlying bedrock, and anthropogenic soils, which formed in human deposited material or fill. Anthropogenic soils are almost anywhere in the urban environment. The purpose of adding fill to an area may be to alleviate undesirable soil properties or to modify the urban landscape for specific activities. Examples of fill materials found in urban soils include natural soil materials that have been moved around by humans, construction debris, materials dredged from waterways, coal ash, municipal solid waste, or a combination of any or all of the above. Characteristics of soil in any urban area depend on many things. They depend on how deep the site has been excavated during construction, and if new materials were brought in and mixed with the original soil materials. They depend on the properties of the original natural soil and the past uses of the site. Many times, topsoil is removed from the site prior to construction and may or may not be returned to the site. After excavation, subsoil may be placed as fill over topsoil. Changing the order of the soil layers or mixing the topsoil and subsoil can alter soil properties. These variables make predicting soil behavior difficult in urban areas. As mentioned earlier, many urban soils differ from natural soils because they have been altered to some degree. They have been excavated, compacted, disturbed, and mixed, and may no longer possess their natural properties and features. Many highly disturbed soils in urban areas or on construction sites have not been in place long enough for the soil forming factors to significantly change them and to form soil horizons. In areas where fill materials have been in place for a considerable time, for example 50 years or so, the formation of A horizons and sometimes weakly expressed B horizons has been documented. Thus, many urban soils possess characteristics that can have serious impact on the ability of plants to grow there. These characteristics exclude those shown here, such as great spatial variability, structure modification and compaction, modified soil reaction, interrupted organic matter and nutrient cycling, surface crusting, which is common for example in tree pits, restricted aeration and drainage, anthropogenic materials. For example, in Washington, D.C., 14% of the city is built on fill, and increased soil temperatures. While not all of these characteristics are present in every urbanized soil, a few are widespread and significant. One of the major ones is the impact of soil manipulation on water movement. We saw earlier that the movement of water into a soil depends heavily on soil texture, soil structure, slope, bulk density, compaction, surface loading, and vegetation. If we consider a natural landscape with plant cover, we see that water moves through the system such that 50% is evapotranspirated by plants, 35% of the surface water is detained or infiltrated, and about 15% becomes surface water runoff. In a more typical urban landscape, water movement is significantly altered. Only 15 to 30% moves through plants by evapotranspiration, 15% surface water is detained or infiltrated through plant-covered surfaces, such as lawns, and no rainfall is detained by impervious surfaces covered with concrete or asphalt. But 55 to 70% of the surface water runs off into streams, lakes, and rivers. So we see that more water moves into the soil on natural landscapes than on disturbed landscapes, such as those in urban areas. More water evaporates into the air on natural landscapes than in areas covered by streets, roads, homes, garages, and other buildings. More water runs off urban areas because of the impervious nature of pavement, compacted soil layers, and urban buildings. Runoff water containing sediment clogs lakes and reservoirs. We saw this also in the unit on soil erosion. Removing this sediment can be actually quite costly. Oil, gas, lawn fertilizer, pesticides, and other pollutants often run off from urban areas and into lakes, streams, or reservoirs and reduce water quality. Some of the fertilizer, pesticides, and herbicides can run through the soil and into groundwater, also impacting urban water quality. Let's consider soil temperatures. This is another important characteristic, more unique to urban soils, is the temperature aspects. Soil temperature may be higher in urban areas than in the surrounding forests and fields. Heat islands form where extensive pavement and large buildings absorb and return heat and restrict airflow within a city. The water supply may be limited in the heat islands as runoff and rainwater are piped to storm drains in the streets. Heat stress can occur in plants in excessively dry soils. Soil water and microbial activity within the soil have a significant impact on subsurface soil temperature. In some urbanized and extensively developed environments, there may be underground utilities that can have an impact on plant performance. For example, buried and aging steam lines that develop leaks have been a constant source of problems for landscapes at the Ohio State University campus. Whether they are in urban or natural areas, soils provide living space and supply air, water, and nutrients for microorganisms and plants. Urban soils that have been disturbed and mixed may no longer possess the natural characteristics needed to support life. So soil amendments may be required to re-establish plants. In many urban areas, the remaining soil materials must be modified before they can support plant and animal life. Some amendment strategies, particularly for the establishment of turf, involve a technique called terra seeding or compost seeding, where the compost base involves fertility, water holding capacity, etc., and produces healthy lawns. In many situations, soil modification to provide support for structures can have an adverse effect on established plant materials, especially mature trees. These trees may suffer from the alteration of the surrounding soil, and techniques to ameliorate compaction, as discussed in the unit on soil compaction, must be followed to minimize damage. Now, after disturbance, the surface layer of urban soils should have the characteristics needed for plant growth. Management includes overcoming physical and chemical root restrictions, providing nutrients by managing soil fertility and acidity, and reducing the likelihood of contamination or disease problems. In areas where the climate is dry, a water supply for the site is also needed. A common practice after introducing plants into newly worked soil is to add organic matter to the surface in the form of mulch. Adding the proper quantity of mulch has many benefits for plants in urban landscapes, such as maintaining soil moisture, ameliorating temperature fluctuations, and introducing organic matter that over time can help build soil quality. However, mulch is not a panacea, and in some situations has become its own problem when used inappropriately. Excessive organic mulch creates highly porous environments where roots will grow readily under good moisture conditions, but where absence of moisture leads to an extremely dry environment and roots may die of desiccation. Urban plants may grow on small islands within disturbed or paved areas. Overland water flow to the vegetation is limited on these islands. Large soil pores that connect to the surface are critical if water is to move to the deep roots of the plants. The soil in the island of vegetation should extend below the pavement and should provide enough volume for root growth in proportion to the above ground height of the trees and shrubs. Trees and flower beds along streets may require more frequent applications of fertilizer and water than backyards or gardens. This ends part 1 of the unit on urban soils.